Hello everyone, just waiting for a few more people to join and then we'll get underway in a minute or so, if that's okay. Okay, right, I think everybody's in. So thank you very much for everybody attending. This is the first of the additive manufacturing digital hours with Additive-X, concentrating on the Markforged 3D printers. We're going to look at the return on investment, about Markforged generally, run through the Eiger software, and then also look at the Blacksmith software, which Markforged have released to complement and go along or enhance their Eiger software platform. So if we first of all cover the Markforged 3D printers. So the term composite printing is widely used in additive manufacturing, and there are a number of 3D printer manufacturers out there that say they do composite 3D printing. When the vast majority of these companies start looking at this material, it's a nylon or a base material with short strand infused carbon fibers. And the Markforged machines use this particular method. So they use a material called onyx, which is a PA6 nylon with short strand fibers infused into it. But where Markforged are very different is the fact that they can add continuous fibers into their print, and we'll demonstrate this on the Eiger software. So we can start looking at adding Kevlar for impact resistancy, continuous carbon fiber for strength, and then fiberglass or high strength, high temp fiberglass for different applications as well. The best way to really think about how Markforged are different from other companies that are dealing in composite printing is if you akin it to reinforced concrete. So Markforged are printing with those rods or with those continuous fibers running through the part to give it that extra strength in the direction depending on the orientation of the part. So as you can see from the two pictures below there, obviously akin to reinforced concrete, but on the other picture it's showing you how the Markforged parts look internally once the reinforced fibers have been added into that. So please keep that in the back of your mind as we head through this presentation, that it is different to other methods of 3D printing and other manufacturers. So Markforged have seven different machines in their composite range, and then they have got a metal 3D printer. But the 7 machines in the composite range are the Onyx 1, Onyx Pro and Mark II, which all have the same build size but vary depending on the materials. And then there is the X3, the X5 and the X7. Again, those 3 printers all have the same footprint in terms of build size, but vary depending on the machine, the materials that can be used in that particular unit. And then you've got the FX20, which is the new offering from Markforged for their industrial, large format industrial platform. The difference between this machine is obviously build size, but it can also print in Ultem 9085, and we can now reinforce Ultem 9085 for those higher temperature applications. The X7 and the FX20 machines are also capable of using Blacksmith, which we'll touch upon later on and run through how that software works and where it's being used for some extra clarification. But as it stands, there are 7 machines in the range, ranging from the Onyx 1, which is around £4,500, up to the FX20. And if anybody would like more information about those particular machines after, please get in touch with myself or the team at Additive-X. So the materials that the machines use, all of them use onyx as a base material. And then as we start to step up into the industrial series, the X3, the X5 and the X7, we start looking at flame retardant onyx, ESD safe onyx as well. And then the FX20, as I mentioned, uses all those materials, and also the Ultem 9085. The Mark II and the X7 can also use a white nylon for those applications that can't use a carbon filled material. So there is the option of just using a white nylon material on those 2 printers as well. And your reinforcement covers, as I mentioned, carbon fiber, fiberglass, Kevlar and high strength, high temp fiberglass. Now, Markforged compare themselves for replacing or strength to weight ratio of 6000 grade aluminium, which you'll see from the graph on the screen. This data sheet is also available as a handout. So if anybody would like to go to the handout section of this platform, and you can download those data sheets from there. What's not on that data sheet at the moment is the Ultem 9085, but we can start to provide that information for you and send that across for tailored application conversations later down the line. That is available at the moment. So if anybody wants information on the Ultem 9085, that can be provided. But the Markforged material data sheet is available in the handout section. There are also two additional materials available for the printers. So you've got, I've already mentioned Onyx FR and Ultem, but the Markforged have released Onyx FRA, which is aimed at the aerospace or aviation markets or automotive markets as well. And they've also got a carbon fiber A, so CFA related material as well for the continuous fibers to go with that for the certification process and traceability of materials that are required, especially within the aerospace sector. So again, if anybody on this webinar has any particular requirements for traceability of material, then we can send details of the FRA material out to you as well for, as you can see on the screen, aerospace, transportation, and particularly the automotive industries as well. And it gives some information under what qualification that's being printed under as well. So we can provide that additional information. So part of this discussion is to look at calculating the return on investment. Now, I've been in the additive industry for 10 years, and starting out, a lot of people would come to us and ask us, can we print a part for the same cost as they were getting it injection molded? And the part costs seem to be the benchmark for comparing pricing and return on investment. Can you produce this for the same price or cheaper than this? The conversation has very much matured and moved away from that in recent years, and we can start looking at, with the advancement of technology, we can start looking at the soft costs surrounding additive manufacturing. It negates raising purchase orders, it negates storing stuff in warehousing and doing stock control or inventory costs, so your stock takes, etc., because you are printing when required, or you are moving to a one part stock holding. You would use that part, print that part, and replenish that part if time is of a key factor, because additive manufacturing still can, in relative terms, take time to print. If you need a part immediately and you've got to wait for 5 hours to print, then it would make sense to hold one on the shelf and replenish that part, and then just have that, I suppose it's just in time stock logistics right on the shop floor, right where it's needed. We also start looking at of late carbon footprint and your logistics costs. If you can reduce the parts requirements to actually being on site within a couple of meters or a couple of 100 meters of where the part is being used, that negates all of that logistics time frame, or carbon footprint and costs as well. And also we then start to look at how that can be managed on a global level. So again, coming back to the Blacksmith software, we'll discuss that further down the webinar on how Blacksmith can use to be verified, so verification of parts and printing parts on demand globally to negate logistics requirements as well. Then we start looking at weight, maintenance intervention, disposal of costs, so disposal of subtractive manufacturing, in terms of the waste material from that, because there is much less waste material in additive. And then we open up the conversation to, can we make part differently? How can we design for additive manufacturing? Will the process allow us to design for additive manufacturing, or can we not alter that at all? In a number of cases we can, and the part can be optimized for 3D printing, be that for weight reduction, be that for quicker printing speeds, be that that it is designed to break in certain areas to save maintenance downstream or upstream on particular manufacturing lines. If we can develop a part that breaks and is a modular repair rather than having to print the full part again. So all of those conversations the team at Additive-X are having with customers day in, day out about where can 3D printing offer that value? And Markforged are really progressive in that side of things. So they've got application engineers which back our team up as well. We do line walks and we do consultation across everything from more of a holistic view of 3D printing to specific part items on lines as well. When customers come to talk to us, we use the Gartner hype curve to manage expectations, and that conversation really goes from what are you expecting, what are you wanting, what material are you using, and often why are you using that material as well, and can we start to have the sensible conversation around heat deflection, temperatures, strength. And when we speak to a lot of people about the strength of parts, you do end up finding out that a lot of companies have over-engineered parts and they are heavier than required. So again, calculating the return on investment is much more than just looking at cost per part, especially when you take into account tooling. And if it's for a very small run, the tooling costs are very often inhibitantly high compared to the price, and they all add to that final cost per part conversation as well. So looking at that, we do have a case study from a company called Labman. Labman are an automation company, as you can see on the screen. They have used 3D printing prior to speaking to ourselves, and as you will see in the video, they had a bit of a torrid time with it and a bad experience. So they took some convincing that additive manufacturing would actually work for them in the long run. And it was a case of easing them gently into the technology again, and proving that the technology has moved on, and that why there is a difference between your sub 500, sub £1,000 printers to looking at a more professional unit and what those bring and what those offer. So Markforged, for example, offer the best finish we have ever seen from any FDM or plastic polymer extrusion machines. It offers good chemical resistance, they offer strength, but the drivers really behind Labman adopting the technology was chemical resistance and the look and feel of parts, the fact that it didn't look 3D printed. So I'm just going to share their story with you, and I will then pick up the conversation after the quick video. So I'm just going to swap screens, so bear with me 1 second.
So we're a custom automation company based in North Yorkshire. We deal with a variety of customers in all sorts of industries. They'll come to us with a problem they want to automate, and we'll work with them from conception to the idea all the way through to build, testing, commissioning, and delivery.
So we've got the Markforged machines for almost 4 years now. They've been absolutely brilliant for what we do, quick turnaround, really good end-use parts. We did have a different FDM machine beforehand that wasn't very reliable. It was a bit hit and miss, and it put a bit of a sour taste in the engineer's mouth. Then we contacted Additive-X. We saw the Markforged systems. We got some sample parts, and everyone was very, very impressed. So we bought one, ran it flat out for a month, realised we need more, and so we've ended up expanding to 6 Markforged units across this site and 2 others.
The Markforged machines, it gives us really, really fast turnaround on some high quality parts, which is crucial for our testing phase.
We use Onyx because it's a very, very stable filament. It's really good chemical compatibility for all the different stuff we use. It's very rare that we get asked to handle like a liquid or substance that reacts with it. So it's a good baseline to start off with, and then if it needs anything specific, we can prototype in the Onyx and then get it made in stainless steel. With the large systems, we tend to take them out. We've taken them all to Liverpool, we've had some go to America, we've got one that's probably going to go out to Singapore, and it just helps the engineers if something does break or they need a quick solution. Instead of us machining something here out of aluminium, sending it across, then waiting a week to get it, it's next day or same day. It really, really helps keep the costs down on site. So we've actually got a dedicated Markforged printer over there at our satellite office, and they can make the changes on site, test it, and implement it straight away. Actually, the Liverpool University saw our Markforged printer there, and they ended up buying one themselves. I think it was from yourselves as well.
It's a great place to work because the projects are so varied. Like I said, we're in many different industries, so from project to project, you could be faced with completely different challenges, which is really great.
We definitely have a plan to possibly purchase some more Markforged systems. Obviously, as we grow as a company, we need the extra capacity to make components, and we tend to find that every single night all the printers are full. So having to queue things up for the next day, run them during the day. So it's full on. It's great to have the flexibility and the capability to make changes on site, because customers always go, we'd like something a little bit different. And it's really easy to pop it on a printer, get it done, get it implemented the same day or next day, and then it gets us home a little bit earlier.
So I hope that shows why Labman have used 3D printing, and it's quite a powerful message when we start looking at they're using it from prototyping through to end-use product, and then on to actually taking the machines on site and using them to enhance their install and service offering, which means then if there's anything that crops up on site, as they said in the video, they can make quick changes and send the parts, either print the parts on site or send the parts to the engineers on site with the 3D printers and print off immediately. They have said to us that that's created, in terms of customer satisfaction, it's increased their customer satisfaction, which is very difficult to put a return on investment on. But if your customers can see you being reactive on site for installs, and also they are, as I mentioned with Liverpool University, if they want a part printing, then or they want a development of a part within the system that they've got, the team at Labman can design that, and instead of shipping logistically the part to Liverpool, which I know granted is not that far and it's still UK to UK, but if you imagine that on a wider scale, they can then just send the file, which is locked down on the Eiger software, straight to the printer and press print, because they own that printer within their fleet within Labman. So very powerful tool, and the customer can come in the next morning, take that part off the printer, and then have it used same day or next day. So really powerful message there. What I'm going to go through now is the Eiger software and show you how we start to add fibers, about some considerations about orientation, and then we'll progress from there on in. So here you can see the Eiger software. So we have the main library here of parts. So if I want to have a look at some different parts here, we can see that this one is onyx, this one is Kevlar and onyx. I've got stainless steel, because don't forget Markforged, as well as the composite machines, also do metal printing. I've got a gripper here, which is for tool steel, and a lot of companies we are seeing investing both in the composite and metal units, because they can prototype in the composite, and then it's a simple drop-down menu and change it straight to a metal printer, and the software takes care of all of the alterations or resizing of that part for the whole sintering process, which is a separate conversation. If anyone would like to have that with us, we can run through that, but we're concentrating on composites at the moment in this particular webinar. So as we look at the part here, I'll just click on this one. We can see as we go into it, it's giving me the dimensions of the part. It's giving me the print time here. It's giving me the mass, and it's also importantly giving me the cost in US dollars. Now, a number of customers ask, can we change that? Unfortunately not, because Markforged deal within so many markets, the price is set in US dollars, but it does give a very good and a very accurate indication of the potential cost of a part. And also the print times are very good on Markforged. You will find some slicing software from some manufacturers, the print times aren't accurate, but Markforged have really concentrated on that. So when we talk about the Digital Forge, Markforged own everything within that ecosystem. Their software, they write themselves. So what you're looking on the screen now, they manufacture their printers, they manufacture their filaments as well. And also the Blacksmith software add-on is a Markforged product. So the whole Digital Forge is all set around and created by the Markforged team. If I wanted to add in note in here, so if I said that this is for line 12 of a production line and it is a part name, for example, so I could just call that a wrench. Yeah, so a line 12 wrench, you can save that, so anybody would have information of what that is. They could also then, if you want to have any details about how that part is used or the installation of that part, we can also put that on as well. So if you're wanting your people who are using the printers to know a little bit more about that part, again, that can be contained within this little bit of information and field here as well. So just going up to this section, you've got your general information here. So you've got your material is onyx, you've got your reinforcement of the part here, and then we can change that to the different machine series. So as I mentioned, we can change it to metal if we want, or we can change it to the industrial series. But just for this example, we'll stick on the desktop series, which is the Onyx 1, the Onyx Pro, and the Mark II. If I want to add reinforcement, you will see here that I've got fiberglass, carbon fiber, Kevlar, or high strength, high temp fiberglass. So let's use the Kevlar because it's nice and easy to see. So I will then go to my settings there. So I've scaled my part up by 0.75. I can change the support angle if I want. If I've got fine details underneath the part, I can raise that part up off the bed to protect any fine writing or any fine details. And then also, if I've got a long, tall, thin part, I'm going to use a cylinder, for example, I could add a brim on there, which would then help keep that part stable during the printing process. And all the way through, you will see these little question marks at the side, and that just gives you additional information on why you would use these particular features on the Markforged system. Infill. So triangular is the default. It's going to give you the best strength to weight ratio, but I can use hexagonal, rectangular, gyroid, or solid fill if I want as well on these particular parts. I can change my infill density. Now on triangular, I can only go down to 28% or up to 55. If I want to alter it from there, that's where I would choose different infill. For example, solid, as it would suggest, would give me nigh on 100%. Because we're using FDM, you are never going to truly get 100%. It turns out around 99% infill. If you really were to inspect it under a microscope, you would see the dots of where the print head has done the crosshatch, but it is a solid infill. We can also do exposed infill as well. Now you'll see there it's in alpha testing. We have used it. It does work. That takes off the top and bottom layers of the print. That's for anybody who's wanting to save that extra little bit of weighting on the part. So it reduces the print times and it reduces the overall weight of the part as well, doing the exposed infill. If I was to start to machine back, if I wanted to machine the part back, I can then increase my roof, floor and wall layers. So I've got something to machine back into before I get into that infill percentage as well. So all of these are useful settings on there. And when I changed it to use the Kevlar, it defaults automatically to an I-beam configuration. So it's doing 6 layers, you can see here, of fiber. And what that is doing is it's putting 3 layers on the bottom and 3 layers on the top in a concentric infill pattern. So it's now starting to use that I-beam configuration for the strength of the part. I can change that. So if I want to do isotropic, I can. Now, when Markforged talk about isotropic, what that does is it will put a layer of the composite, the continuous composite, so Kevlar or carbon fiber. It'll put it down into 4 layers, and it'll change the angle on every layer of that part. And then it'll cover it with a layer of onyx, and then you can choose where you want to do that within the part as well, which I'll run through on the internal view in a minute. If I just wanted to strengthen the internal holes of a part, I can do that. I can do the outer shell, or I can do both inner and outer. So the inner holes are useful if I'm doing if I'm putting screws, or if I'm using nuts and bolts and screwing a part together, and you want some torsional strength or some bite onto that part, we would beef up where the inner holes are, or the reinforcement around the inner holes, to give it that torsional strength. That not only works for strength, but it also works for your engineers to create that extra reassurance that there's some bite and something to screw or to use the torque wrench onto the part in, and they're not worried that it's going to compress because you've got that additional layer on there as well. So I will just go back to the settings here, or general. So you see I've got Kevlar. Let's save that. So all of this is done via cloud, which is really useful for the vast majority of companies. Those companies that can't use cloud software, there is an offline Eiger version available that is chargeable. The cloud version is free. So again, Markforged are one of the only, if not the only, 3D printer manufacturer and software company that writes their own software that has got an ISO certification for the security of their software as well. So again, if anybody would like the ISO certification and the white paper that they've done on their security of their software, I can send that through to you as well after this. So you will see adding the Kevlar has increased the price to $2.12. It's increased the print time slightly, and what we can do now is look at the internal view. So what this is giving you is the internal view of where the fiber is being added. So you will see across the bottom here that we've got the 2 strands of fiber, or the 2 concentric rings. So you will see there, if I did want to add something in the middle of here, for example, it's a case of just doing that. I can then start to do my fiber. I can again choose all the settings I've just ran through before. Do I want to use concentric or isotropic? Do I want to use the walls for the whole part, or the inner or outer only? And how many concentric rings do I want? If I'm using isotropic, I can start to change the rotation point of a part, because if it's starting where the weak point is, you want to change that. So I can start to change where the rotation of the continuous fiber is as well. So I will create that group in the middle. You will see that we'll start to add it to this section. Which is now done. And now you will see that is now in with the 4 concentric rings in there as well. What I can also do on this particular piece of software is I can start looking at a 2D view. So if I wanted to start to go and look at, this is my base layers. If I wanted to then look at my continuous fibers, I can do. And this is where I was saying about, we can start to look where the layers start and stop. And if I want to change that, I can. But if that was a particular weak point and I wanted the start stop to be in this section, you can start to change where that is by moving it around a particular part on this parameter here. And as mentioned, we can start to scan through. So it covers the continuous fiber with a layer of onyx all the time, just to seal that in. And then you start going back to your infill here, which we had is triangular. A couple of other nice features to mention in this software is if I wanted to add in encapsulated parts, so if I wanted to put in encapsulated nuts, if I wanted to put in wear pads, we have companies that have started using the NFC or the RFID chips and creating cavities and embedding those in as well. I can here add in a pause layer at whatever layer height I want. Obviously, when you're looking at that, it has to be just where the part or where the hole is ready to close off, because what you don't want is the part that you've put in or embedding to be higher than your current print level, otherwise the head will hit into that. So, but it is a very useful feature. We use it internally for embedding magnets and also embedding things like, as I mentioned, nuts, etc., and screw threads into there as well. And I can also add in a scan layer, which I'll come back onto after this, but this adds in a scan layer of that particular part. The reason we can add in a scan layer in this section is that it will give you a verification of how the internals are looking within a part. So if you're doing batch processing or batch production and you want to see if the infill is the same on layer 5 of 60 across a certain amount of parts, it will scan it, and it will scan it at every layer or every part at layer 15, so you can verify and check what those parts look like. It's very easy to toggle on and off as well. So if you wanted to check 1 or 2, you can do. If you wanted to turn it off for the rest, you just download the file with all of the settings, and then you would just remove that on the internal section as well. So I'm just going to save that with the 3 layers in and go back to my part view. So again, you can see here, it's gone to $2.50 on there. Now, some people ask about orientation, and we are going to look at that as well. So if your part is the stresses are pulling up and down, so are pulling the part apart, it stands to reason that we are using fused deposition modeling or fused filament fabrication, so extrusion printing, and it stands to reason it would still delaminate in that Z-axis. So it's all about understanding the part. It's all about understanding the orientation that you would need to print that part, and also how to strengthen that part as well. Now, the team at Additive-X can help people do that, and that's part of our role. We don't just sell printers. We would advise people on how to print parts, especially after investing in printers. We're here to back them up and to help with the first parts they are printing as a consultation as well. But the software as well is very easy to use for reorientating parts. Now, bearing in mind, I've set my fiber strategy for this orientation, so it will start to change and I will have to revisit that. But if I wanted to print the part in that orientation, it's a case of just clicking on the relevant face that I want it to print on. If I want to do it manually, again, that is also an option to be able to do that as well. So let's say I want to save it in that orientation. I can save it. It's asking me that, it's telling me that it will overwrite internal edits, so I will do that. Now, again, what a really nice feature of this software is, and I'll just wait till it goes, is that it will start to save the different versions of this particular file. So you can see if you've printed it and it's not worked as well as the previous version, you don't have to go back and do all of the resetting. You can just roll back the different versions of that part and start picking those up. So if I revert to that, this is the original one I did this morning. You can see it's changed the orientation back to this particular one as well. So that is the Eiger software for adding the fibers. If anybody wants a more in-depth overview with a part of their choosing, we can happily arrange that via a Teams screen share. But we would need to know a little bit about that part, about the weighting or where the forces are within that part as well. But we can absolutely do a one-on-one Teams screen share with anybody who's wanting an individual part analysis with us. So just going back to the library. So we've got here the dashboard, and again, a nice feature. So we can see how many parts we've printed. We can see how many users Additive-X have on our system, and we can see how many printers or devices we've got hooked up to the Eiger cloud software, which means we can download CSV files. We can look at what we've been printing in the last quarter, the last year. We can have a look at what users have been using the machines, etc. And we can start to extract all of those data, all of that data as CSV files. Markforged also have a piece of software called Eiger Fleet. So if you've got multiple machines within your organization, you can limit access control as well. So you can have people who set files but can't print. And then you can have people who obviously can set files, can set the orientation in the fibers and print as well. And then you can have control over certain levels within that organization and visibility of the machine. So Eiger Fleet enables all of that in the background as well. So that's a really nice feature. And then just go back to the library, and then we are back into our library of parts, and I can start then, if I want to look at all the parts by name, or if I want to look at them by material, I can just type in here. So if I typed in onyx, it would bring up all the onyx parts I've got, or stainless steel would do that, copper, etc. It would filter all of those by that as well. So a really nice piece of software. I'll stop sharing my screen for a second and go back to the presentation. So bear with me. Okay, so we've covered the Labman case study in Eiger. So we looked at strengthening parts with the continuous fibers. There are cases where that can't be done. So you have parameters where we can fit in fiber. So if you are wanting the minimum thickness or minimum area we can place fiber in is 2.9 mil. So if you've got parts which don't have areas that are thicker than 2.9 mil, the fibers will not run through those parts. And this example on the screen now is an example from a company where they were trying to strengthen up this particular area. You can just see here. Now we could run one strand of fiber through that, but that really wasn't offering any advantage in terms of strength, because you really should have something that can get in, double back on itself and come back to offer any real rigidity. So one fiber strand isn't really going to improve the strength that much. So the conversation with this customer progressed, and they couldn't add the fibers to where they wanted, as I mentioned, in this particular area of the part. So we started discussing design for additive manufacturing. And as I mentioned at the start, with looking at return on investment, how can we alter that design? How can we start to improve or amend without having to retool, which additive manufacturing lends itself perfectly to? This particular part was an ideal example, because a very simple solution, but one their engineers hadn't thought of because they hadn't realized the capability or the power or advantage of additive. So what we've done here is we have then taken the part and we put in a diamond shape hole. Now we put in a diamond shape because it didn't need support structure. So anything with diamond shapes or teardrop shapes in generally don't need support structure on FDM technology. So if we can avoid circles, it's ideal, because the roof of the circle still needs supporting. So for example, if you've got a channel running through your part, and if it does need to be circular for the inners or for the ends to screw things into or onto for attachments, there is again the argument you can create the outer or the plugs, if you like, the entry points as circles, and then that changes to a diamond shape or the teardrop shape running through the part, and then you've just got that support structure to pull out of the plugs of the part rather than through the entire channel. But this particular company, we used the diamond shape so we could insert rods into the part. Now that rod was pushed from this part, from this section here, all the way through and went through to the back end of the part, as you can see in this particular picture. So that strengthened up this particular area which was weak. Even when they were injection molding the parts, it was weak. That's why they were starting to look at additive manufacturing to see if they could further enhance or beef up this part. So the rod ended up going through and into this section here, and that worked really nicely for that particular customer. So moving on to Blacksmith software. So Blacksmith is an enhancement to Eiger. It's a paid for enhancement, but it does add a massive amount of value for negating any bottlenecks after 3D printing, and also the verification of parts. So a lot of the questions we get asked as value-added partners or resellers is that how accurate are your 3D printers, and how can we ensure that a part is the same from one printer to the next, etc. And as we start to look at the global logistics market, and as we start to look at how 3D printing can be used on a more global level, then this is where Blacksmith comes into play. So you calibrate your machine, you print and scan the part, you analyze the data, and you generate a report. Now, how that works in practice is that you get a calibration bed when you upgrade the Eiger software to include Blacksmith, and that calibration bed is CNC machined, so it's got a set datum on it. The X7 and the FX20, which are the two machines that use Blacksmith, have in-process inspection laser scanners on them, and that scanner then references itself to that datum set of the CNC reference bed. And it sets itself according to that. So each printer that uses Blacksmith has a reference bed to go with it, and the scanner is calibrated to that reference bed, which is, as I say, being CNC machined. What we then do is we can use that as that set datum point, and as we start looking at files on that, the file will print, and it will then give us a readout or scan report of that part. So that's advantageous if you've got critical surfaces. You know the tolerance of that surface because you've got a scan data report of it. And also if you are printing the part globally, so twofold, you can send the scan data report out with the part if it's a more local print or to your customer or end user. And also you can then send the digital file, which you can lock down in the Markforged software. So where we showed you the adding the continuous fibers and the orientation, you lock that down and nobody can see that. It's a case of pressing print on the printer. So you send that data to the other user, or if it's in your organization and with that fleet access, you can send it directly. You send that, and you also send the data and scan report from that. Now, where that goes with the printer is once it's then scanned at the other end, it produces a scan report and you get that verification match, or you can have a look at the differential of the two printers, because we're still using belts and pulleys, but you can see whether that is in and out of your accepted tolerances in that case. So trusted parts off the print bed, accessible and integrated workflow. So it's negating in some cases CMM checking, not in all cases, but if you've printed a part quickly but you still go into a queue for CMM checking, that's still adding a lead time onto that part. Whereas if you can do it and you've got the report straight off the print bed, that's negating that scan check, and then you are, as I've mentioned, increasing fleet conformity. So I'll show you a little bit of the Eiger software with Blacksmith on, so you get more of a feel for that. Again, we can run through this with anybody who needs a more one-on-one overview of it. So back to our Eiger software, you'll see we've got a part here that's saying Blacksmith and builds. So let's go on to here. I will use this. This is a lolly stick that we print out as a sample part. So we will then see here that we have got the scan point deviation and data. So we go down to minus 250 micron and we go up to 250, so minus and plus. And we can then start to see on this part, sorry, just while it fills it in, you will give you some example. You can start to see the data points. Apologies, that's not loading quicker on my system, but you will start to see where it is saying it's in and out of tolerance of the part. So you will then start to see the features disappearing. So you will see that I'm minus more than I'm over on this particular part. And you will see there that it's on the top of the X here, where the deviation is taking place. There you go, that's a better view. Right, there we go. So you can see how it's starting to look on that particular part there. So again, I've got that on the side features of the part as well. So I can start looking at how that is across that particular part and where my tolerances are in and out of that particular item. Now, if I want to download the scan report, I can do so. I'll just have a look at that for you, show you what that looks like. So what we're going to do after this webinar is we will send out a part. We will send out the scan data report as well. So you receive part and the data from that part so you can see how that all looks. So we've got here the name of the part. We've got what data was initially printed and scanned. We've got some information with regards to what reinforcement. So we didn't use reinforcement in this particular item, what layer height it was printed at, the dimensions, and then it's giving us the standard deviation and the mean deviation of the scan data report. I can add in notes on Blacksmith as well. So again, like I mentioned before, how the part is used or etc. I can add in notes about the scan, and then it gives me a heat map of the surface deviation on here as well. So we will, for those people in the UK, when we finish this webinar, we'll print some parts, we will scan them, and we will send the surface or the scan report data off with that, which I hope is of some use. Now, a new feature which has just been added in Blacksmith is the ability to pick certain areas for scanning. So the feedback Markforged received was that a lot of customers who were looking at this software didn't need all of the part scanning. They just wanted the critical faces scanned. So they've actually made an enhancement to their software, which was quite quick. And we can now go in and highlight particular areas that we want scanning on the part. So it will just scan those areas and it will produce a report of those critical faces. Just while that's loading up, you can see here we've got a low, medium or high resolution scan. So if I wasn't picking any face to be scanned in particular, it would do the whole part. You can see the high resolution would mean it would scan at every 1.5 mil on that part. So after every 1.5 mil is printed, it would start to scan and it would do a high resolution of that scan as well. So let's just say that as I've manufactured this part, if that was my critical face, or let's pick the internal, if that was my critical face, you'll see there that it's created a group now for me to scan that particular part. So that would override the scan every 1.5 mil, and it would scan that part as it's printing, and it wouldn't scan the whole thing. So every 1.5 mil, it would scan that section here within this group. So I can do different groupings. If I want to group the inside of that A and the internal face of that as well, again, I can do that. I can save that. And that's going to be my second feature. So again, it would scan that area and the internal hole during that as well. So that would be a scan, and that would be a scan. So as it's printing on the XY, the scanner would do those every 1.5 mil. If I was to look at the low resolution, it would do it every 6 mil on the part, and medium is every 3 mil. So 1.5, 3, and 6 mil on the Z height are your scan levels on there. So this is just a brand new feature. I haven't got the heat map from this because it was only added very recently, and we need to print some parts off and do some scan data on this, but it will work exactly the same as the report I've shown you already. So just going back to my other screen, because I know we're heading towards the end of the hour. So that's another example of the scan data report there on that. So that's the one I've shown you from the Blacksmith software. Again, that's what we'll be sending out to people on the part that we've picked and done. And that is everything from me. Has anybody got any questions? If so, I believe you can put them in the chat. I'll just have a quick look on there. Does that mean that one wouldn't need to use a third-party CAD software for the design? No, you still need to use a CAD software, be it Fusion 360, SolidWorks, etc., whichever you're using, Siemens NX. So you would still use the third-party CAD software for your design, but you would export via STL file, and you can then upload that into the Eiger software. So the Eiger, sorry if I didn't make that clear at the start, the Eiger software is not CAD software, it is slicing software. That's where you slice and add your continuous fibers and do the orientation, etc. On that. Does anybody else have any questions following that? Just give it a minute, see if anybody's typing. No, doesn't look like anybody's sending anything through. If anybody would like to contact me, my email address is on the screen. I do believe you get a recording of this webinar as well. We do have another two. They're going to be the same content, but please keep an eye on the Additive-X websites, etc., because we will have some additional content coming soon. And thank you all for attending. Thank you.